So just a quickie really to show you what we're aiming towards in this project. Now, because I haven't finished the section, I can't show you how it's going to look at the end of the section, but I can show you the beginnings of my prototype, which are going to involve clicking to move. So we're going to click up, move within range, and start attacking with this ridiculous over-the-top kind of left arm hook. And we're doing that with a spaced repetition interval, and I can cancel at any time by clicking over anywhere else in the world. So only when I click on a target does it move within range to attack. And if any point I click away, even when I'm running towards it, I will cancel my attack like the chicken that I am. But there is going to be more to it than this. We are going to be doing click to attack. We're going to be doing the animations. We're going to be repeating the animations. As you saw there, it was doing it with a bit of delay. We're going to be doing all of that. We're going to be dealing with damage dealing and death as well of the capsule. So the capsule will probably just disappear by the end of this. But don't worry, we will make this into a system later down the line that works both ways, so the capsule will be an enemy that can attack us back. That will be the subject of the next section, but in this section we're going to get just this whacking stuff and doing damage to work. Hello and welcome. Not much different here. We're still moving around as we did before. The only difference is that now on our player, as well as our mover script, we have also a player controller script, and that player controller script is what's responsible for doing the raycasting. The mover script is what's responsible for doing the movement. We've separated those two apart, and I'll tell you about all the great benefits about this, such as getting AI movement practically for free. So let's dive in and see how to do this. Okay, so the first thing we're going to want to do in this section is the ability to click on an object so that we can then target it for our attack, move towards it, then play an attack animation. But the first stage of that is going to be that control step of clicking on the object. Now, I'm going to just get us to visualize this in this lecture because we're not actually going to be doing anything to do with actually clicking on the object. We're going to be doing a mini refactor. But I do want to be able to visualize it. So in the sandbox level, I'm going to go and right-click in the hierarchy, go to 3D object capsule and create us a little capsule here. This is going to be the enemy, quote unquote, and I am going to make it a little bit funny because I think this is a bit dull. As a normal capsule, I'm going to make it kind of short and squat, and I'm going to pop it over on the ground here. So this is our short and squat enemy. And while we're at it, let's rename it to enemy rather than capsule to make our imaginations really flow. And I'm going to prefab it as well. Now this is going to go in the game folder because it is a designer hat type thing. It is a prefab. It is an asset created in Unity, in the Unity editor. And it's going to go under characters. And I'm going to drag it in there. So we've got a player, we've got an enemy. It seems to be making sense. If we go ahead and hit play, let me just illustrate what I'd like to be able to do is hover my mouse over the enemy and click on it. And at the moment I walk to that location, but I would like to walk within range of my attack, so stop a little bit before, like this, and then start beating the enemy up. So how are we going to do that? Well, we're going to need to do some raycasting to try and find this component, but before we start on all that, where should that code live? Because as it currently stands, this is a file that was deleted, so you shouldn't have seen that. Whoopsie daisies. So as it currently stands, our raycasting is happening here in the mover script, the mover CS script. And the point is that the right place for us to be doing raycasting also for the whether we hit something on combat? Movement's not the right place to do combat, is it? And this is quite shared logic. We're going to want to do a lot of this screen point to ray stuff again. So maybe this all starts to need to be pointing towards being in the same class. So let's have a think about that. How could this work? By separating out a control layer. At the moment, everything's in the mover, but I'm suggesting pulling it out into something, for example, called a player controller class. And that's going to be dealing with the raycasting. It'll tell the mover to do the movement, and then that's all good. The benefit of this is that then the player controller can be used to drive things like a combat class as well, separately to the mover class. And also, a great benefit here is that if we have our interface right for the mover and for combat, we can then swap out our player controller with an enemy controller, and sharing the exact same movement code, the exact same combat code, we are able to have AI control a character So we can pretty much use the same code and really reduce our development costs. And beyond this, you might have other components that are driven by the player controller but not the enemy controller, such as special actions. All of that is possible, and it's a nice kind of separation of concerns. So how are we going to do this? What parts of code do we want? Which parts don't we want? What is a good interface to the movement class? Well, I would propose that a good interface to the movement class is something that just enables us to move to a particular destination. So if I hover over this, the get component nav mesh agent, if I select that, you'll see a little light bulb comes up next to my cursor. And if I click on that light bulb, I can go and hit extract method. And this pulls out a new method, and I can rename the method to be something along the lines of move to. Now, as it stands, this is passing in a hit. I don't think that's quite right. I don't think we should be moving to a hit. I think we should be moving to a destination. So let's just take this hit point out, and we're going to pass that in as the argument instead. So what's a hit point? If I hover over it, it tells me that it is a vector 3. So that seems to make sense. Move to vector 3 is going to be about the right level of API, and that's going to be the destination. So I'm saying that our interface, in fact, because it's an interface, we're going to want to make it public, so it can be called from outside of the mover class, is going to be void. It doesn't return anything. Move to is the name, and the argument is going to be vector 3, because that's the destination. It's basically the command we're giving. And I can go and set the destination of the nav mesh agent from that destination. It's pretty straightforward. It does a very simple job, this move to. And as you can see, we're now calling that in our move to cursor instead. Also, what we don't want to be doing is in update of our mover, we don't want to be checking our mouse down and doing this move to cursor call here. So I'm going to comment that out. I'm going to do that with a little shortcut for Visual Studio of selecting that code that I want to comment and then doing Control / comments out all those lines. On Mac, it might be slightly different. Check out your guides about shortcuts. I think you can look at the keyboard shortcut reference from down in Help, and you will be able to see what that keyboard shortcut is for you. So basically, yep, we have been able to comment out that code. Now, the mover's working as we would want it to work, with a separated control layer, albeit there's some extra code in here, but nothing is currently calling move to, and that's going to be your challenge, to create something that does call to move to. So we're going to create the player controller class. It's going to call move to function. It should work as before, and bear in mind, you should not forget to add to your player prefab. The player controller should belong on that root object, same as move to. Eventually combat will live there too, so that it can get hold of the mover mono behavior. It will be a mono behavior itself, not just a class, a mono behavior that will do all the querying for raycasting and eventually call the move to function. You might just, at the moment, you don't really need to create any new code, so it's just moving code around. Pause the video and have a go at this challenge. Okay, welcome back. So we're going to create a new script to do this. You can do it from the editor, like you used to. You can go to the editor and create a new script in here. I'm just going to show you that you can do it from Visual Studio Code as well. So we've got a script folder, and we've got core, we've got movement. I believe that what we've got here is a new feature. It is control, and we're going to want to keep things separate. So I'm going to create a new folder here called control under the scripts folder, and in that I can create a new file, and I can call it player controller.cs, like so. Now, this is exactly the same as if I had created it in Unity. You'll see that if I go into my Asset Explorer and go down in the scripts folder, you can see there's a control folder created here, and there's a player control CS, which is currently empty. So it won't work. I can't pop it on a character because it hasn't got a mono behavior in it. So the next step is to write the mono behavior kind of boilerplate code. And fortunately, Visual Studio Code actually has some way of doing this automatically called a snippet. So if I start typing mono behavior, you can see it's giving me some autocomplete options. And if I hit tab on that, it fills out the mono behavior boilerplate automatically for me. So I don't even have to go back to Unity if I want to create lots of scripts over here in Visual Studio Code. And that's cool because one other thing it's done here is it's noticed the name of the C# script and it has put it as my class name. So that's a little bit of intelligence going on there as well. Obviously, if you'd done it via Unity, it would have done the same thing. I just sometimes find it easier when I'm in this context to stay in Visual Studio Code. You might find that interesting. Okay, so the player controller. First things first, it's going to have this code, the move to cursor code, essentially. I'm going to cut that out. And I'm going to move it over into this C# script. You'll notice it isn't currently able to call move to because it doesn't have this method on this mono behavior. We need to call to and get the mover mono behavior. So we know how to do that. It is get component of type mover, like so, dot, and then I can join those two lines together. So get component mover dot move to. That makes sense. It works there. There's nothing calling move to cursor. So there's that code I commented out from update. If I cut that and we go and create an update in our player controller. Again, there's a snippet for this. If I type update, I can tab complete and it creates an update method for me. And I can paste that code in here. I want to go and uncomment it. I think it's exactly the same keyboard shortcut, control / uncomment the code. And yeah, it's working because this function is there. It is checking that the mouse button is down, then it is calling move to cursor. So that's pretty neat, pretty straightforward. Now you can see that our mover C# script is very, very tight indeed. Does not too much. It updates the animator. It is responsible for controlling the navmesh agent. And the player controller is the one responsible for doing raycast and so forth. And we will be able to use this to expand our raycasting ability to raycast to components, not just to the terrain. So I'm pretty happy with that. Let's check that it's all working. As I said, I have to edit the prefab of player. Now, Rick has been doing that from the scene. You can also do that in the new prefab editor that is new in 2018.3. And you can do this in one of two ways. You can use the little arrow next to any of your prefabs to open the prefab editor and edit the asset directly, or you can find the prefab in your asset hierarchy. So in game characters, I could open the prefab from here as well by double clicking it, but I want to show you the arrow. If I click on the arrow, boom, we are in a special scene, especially for editing this prefab. If I want to go back to the main scene, there's a little arrow just next to the player at the top of the hierarchy, and that takes me back to the main scene. I can do that for any of these prefabs. Go and edit the prefab directly. That means I don't have to apply any changes back because they've already been applied on the prefab. So you can see this is laid out exactly as you'd expect. There's a little mini hierarchy. In fact, there's another prefab in here. I could then edit that prefab as well. It's a different prefab. That Knight Soldier is a different prefab. We're not going to be editing that, though, because it's in the asset pack, and we shouldn't touch things that are in the asset pack. So we're just including a prefab within a prefab. That's something new that you can do in 2018.3. Pretty cool, I think. But anyway, the point that we're here for is pretty simple. We just want to add a script to our player. So I'm going to go to the root of player, where we've got our mover script, our navmesh agent, and add a new component. It's going to be a player controller component, and boom, let's go ahead and hit play. Can hit play from this kind of prefab editing scene. It will use the scene I was last in, and hopefully, yep, I can still navigate and move, which means that our raycasting must be working and our mover script communication is all hunky-dory. Hopefully you didn't struggle too much with that challenge. If you struggled a bit, that's absolutely fine, and you had to watch the challenge, the challenge solution, that's absolutely fine too. Hopefully you learned something from what you missed out on. That is a great learning as well. Great stuff. I'll see you in the next video. Hello and welcome to this lecture on dependencies. We're going to be learning how to manage dependency hell, where if you modify one class, everything starts to break down, and how we can keep that going when we've got massive class hierarchies like this and keep the dependencies as low as possible between all of our classes and all of our namespaces. We're going to be learning about namespaces, how to use them, how to create them. So let's dive in and see what this is all about. So we have started to lay out our scripts in these different folders under control, core, movement, and so on. But there's nothing that actually keeps us honest to this in the code. This is just for our organization. I'd like to talk a little bit about something called namespaces and why we might want to use them. You've actually used namespaces before, you might not realize it, but when you do using Unity Engine, that is including the Unity Engine namespace, and that's what allows you to use things like the ray and the raycast and the camera and so on and so forth. Basically, all these names are included in the namespace. It restricts the ability to clash, basically, because if you had another module that required a camera, it could use it as long as it was in a different namespace to the Unity Engine namespace. But why might we want to use these? So the problem is that dependencies are evil. We need dependencies in any program, obviously, because things need to cooperate with each other. You know, it would be useless to have a perfect combat system if it didn't communicate with movement and wasn't controlled by a control system. So imagine we have this dependency structure between our different namespaces of our, well, basically our features. Let's just call them features for now, and we'll use namespaces later on. Imagine we have this situation. In movement, we have our movement component, and it has a script to move to, which is shared between combat and control, because combat uses it to move towards the enemy, whereas control uses it just to move when you point and click. So both of these make sense, but what happens if we make a change to movement? We could do this, for example, by changing the return type of move to. Now it might return a Boolean and potentially fail to move. That means that now what could change as a result of that one change to movement? Well, we can go backwards along these dependency arrows to see what could change. Combat could change, for example. We might need to decide what to do in the eventuality that movement fails. Control might fail as well. We need to show some affordance when we fail to move to a certain location so the player knows why we are failing to move. Now, obviously, not every change in movement is going to break something in combat and control, but it is a possibility and it's something we have to test. So that's why dependencies are evil, and as much as possible we try and reduce the impact of dependencies if we can manage it. Not always, okay? We're not going to be able to do everything, but we don't want to have a situation where movement depends on control, on combat, on core, and blah, 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 blah. Now, if dependencies are evil, then cycles are even worse. So this is a cycle because it's a dependency cycle, because if I go from control, I can go down to combat, I can go down to core, and I can find my way back to control. So I've created this cycle of dependencies. In fact, there's more than one cycle here. I could go via movement. I could go via movement core. You know, there's cycles, lots and lots of cycles. Now, what if I make that same change to movement? What can be affected now? Have a little think. Maybe pause the video and think what could be affected now in this. Well, core and combat still the same as before, but now we can follow this dependency, this circular dependency back to core, which means that core can be affected, and funnily enough, movement itself can also be broken by a change to movement in a way that you weren't expecting. So you change something over here, but hey, via that dependency on core that got changed by the dependency on control, something broke. So this is obviously not great, and this is how cycles can just propagate this problem of dependencies further and further and further and just make your life a nightmare. So what we try and do is, without a doubt, always try to avoid cycles. And what happens, interestingly enough, when you try and avoid cycles is you get something called layering. So this is the layout structure of my prototype. And obviously it's very complicated. There's lots of dependencies, but not as many as there could have been, right? You know, the combat depends on 5 things. It doesn't depend on 10 things. The movement only depends on 2 things, saving and core, and so on. Now, what you'll notice here is that you can arrange them in layers where none of the modules reference anything higher up. So inventories doesn't mention anything about combat or special actions or UI or control. It doesn't rely on any of that because it's a lower layer dependency. And the lowest layer dependency have basically no internal dependencies within these modules. They might depend on stuff in C# or in Unity, but they don't depend on anything within our project. These are the lowest layer dependencies. And interestingly enough, what happens here is that you have stability increasing as you go down the layers, and that's a requirement for stability. So what I mean by that is that we need to change these classes less, or if we change these classes, it's going to destabilize our project. And you can kind of see this. If I change the way my saving system works, I've got to think about everything, because everything depends on my saving system. I've got to think about how that affects questing, and as a result, how does that affect the dialogue system and the UI? How does it affect combat and control, because these lines go all the way up to control? So you have to have the lower layers as stable as possible, as unchanging as possible, and the higher layers are the ones where you can do lots of changing. So control can change a lot because it has very little dependencies on it. So this is just a little bit of an overview of why we are going to be using namespaces. It allows us to really kind of see the picture of this stuff through the using statements, because in combat I will see, in a combat namespace, I will see that it is using saving, it's using core, it's using stats, it is using inventories, and it's using movement. And that allows me to really kind of highlight the dependencies and be cognizant of them. When I'm adding a new dependency, when I'm writing a new using line, I'm having to think twice about doing that. And is that really a dependency I want to add to this graph? Is it something that I want to add in terms of complications to my project? So it allows us to essentially firewall our features. Now, a flip side of this is that within a namespace, you want things to be as cohesive as possible. And what that means is that they should try as much as possible to be related to one another, so they probably need to be using each other's classes. So here's an example of a not very cohesive namespace, right? The combat system depends on damage text and health, and the weapon config depends on damage range. But between these two, they could kind of be separate namespaces, right? This one over here could be one namespace. This one over here could be another namespace, because they don't have very much to do with each other. Now, in reality, this namespace is more like this, where the combat system does rely on weapon config and damage range. And this is more cohesive now, because everything relates to something else in the namespace, and it's pretty much, you can't pull any of this out. It's not completely cohesive. It's not as cohesive as it could be. If I added in more dependencies like this would be a really cohesive namespace. We don't necessarily want to go for maximum cohesion within a namespace, because all these dependencies do add complexity, and it means that if I change the health system, I could I could change any of these other systems or C# script in here. So you still want to minimize dependencies, but you want to make sure that within a namespace, you've only got things that are really related to one another. So with that said, let's go and apply this in practice. How do you create a namespace? It's fairly straightforward. I'm going to do it with our player controller first of all. So the player controller, if I go ahead and cut out the class definition, because I'm going to stick it inside a namespace, I can use the keyword namespace, and then I can name the namespace. And now the way I'm going to do this is starting off with a prefix. Namespaces are hierarchical, so you can have RPG dot, and I'm going to call it control. So this is going to match with the structure of the folders that we've got. You could have rpg.control dot something else as well if you wanted. You can keep it hierarchical. We're starting with RPG so that if we import anything else called control, it doesn't conflict if there's any other module that you're using. The fact that we started it with RPG hopefully will keep us safe from conflicts. So this is RPG control namespace, and then you have curly brackets to define things that should go in that namespace. And that's where I'm going to paste in the definition of our player controller. So now, whenever we want to use the player controller somewhere else in another namespace, in the same namespace, it's going to be fine. If you have namespace RPG control, you can just use player controller. But if you are outside of the namespace, you will need to have a using statement. So this is going to be the challenge for you folks, to namespace the remaining two classes that we've got. So each class should be in its own namespace. Name it appropriately, as we have with our folders. Add any using statements you need to use. You might find that you already have some dependencies between these different namespaces. And what do the dependencies look like? Get out a piece of pen and paper and map out all the dependencies between your namespaces. Pause the video and have a go at this challenge. Okay, so welcome back. What we're going to do is we're going to go into, the next one is the follow camera. It is in this core folder, so I think it's going to be in a core namespace. I'm going to cut out the class and again use namespace, and there is actually a snippet here in Visual Studio that I'm going to autocomplete, and it kind of pops in some of the boilerplate for me. It's going to be RPG prefixed again because it's everything relating to our project is going to be under this RPG namespace, and then instead of control, which it's trying to autocomplete for me, I'm going to create a new namespace called core. You don't actually declare namespaces anywhere. If you use one, it's created it. And then in the body of namespace, I can paste that follow camera class back in. And finally, in the mover script, I'm going to go ahead and cut out our mover, like so. And I'm going to add a namespace, as you might have guessed. It's going to be RPG dot, can you guess it, movement as the folder. I'm trying to keep it the same as the folder. And then in the body, I can paste our mover class back in. Now, I am getting a little red thing here in Visual Studio Code. Let me just check this over in Unity as well. I should be able to go to the console and see that it's saying in the player controller class, if I go over to that player controller class, oops, it's opening up in a different place. The player controller class, I've got a red squiggly under mover here. And why is that? Why do I have this red squiggly? If you click on the little show fixes button with a little light bulb, it'll say that you need to be including using RPG movement. There you go. So we've got our first using statement in here saying using RPG movement, which is including our own module called movement, and we can see now that there is a dependency between our control module and our movement module, as we might well expect. So let's have a little look. If I were to draw out my dependencies, I've got 3 modules or 3 namespaces called control, movement, and core, and that is the dependency. That's the only dependency we've currently got. We're going to hope to see more dependencies, ones between movement and core, for example, or when we add in a combat module, we're expecting to see at least a dependency between these two. So we've got control and combat, control depending on combat, basically. So hopefully that elucidates why you might want to use namespaces, why dependencies are evil and we want to reduce them as much as possible. I know it's early at this stage, we've got 3 classes, but trust me, an RPG becomes big very quickly, and you are going to want to have this in the back of your mind while you're doing it so that we don't get ourselves into a dependency hell. Hopefully you enjoyed this lecture. Let me know what you think over in the discussions, and I'll see you in the next one. Hello and welcome. This lecture is about getting to the first stage of our fighting system, fighting input, where if we, let me clear the log, if we click on our enemy capsule, then it prints out a log message. And this log message is actually coming from a fighter component on the player. So that's the starting point where we're going to actually start a procedure to attack the component, the enemy here from our player. This is the starting point, getting that input to the fighter component. So let's dive in and see how it's done. So at the moment, we've got an enemy, but we have no way of attacking it. So what we want to do is introduce both a component for combat, for us to be able to fight, and for us to be able to activate that component by clicking on the enemy. So the logical place for a component for us to do some fighting is going to be on the player itself. And we're going to need a new script for that. So I'm going to go ahead and create a new file, a new folder first of all. So let's go into the scripts and create a folder there. And it's going to be called combat. And under that, I am going to create a C# script called fighter.cs. And in there, I am going to create a monobehavior. I'm going to use the snippet in VS Code. And I'm going to stick that in a namespace. Now that we've started this good practice of using namespaces, I'm going to create a namespace for, let me use the snippet, rpg.combat. So that's created a new namespace because we didn't have it before. And I can put my fighter script in there. What's our fighter going to do? Well, it's public API. At the moment, let's just keep it simple. It's going to attack something. It's going to take nothing, return void, and it's going to attack. And at the moment, because we don't have anything that it can actually do, I'm going to just print something out and be like, Hey, take that, you short squat peasant, something like that. So there's obviously going to be proper functionality in here that involves moving to the target and then actually playing attack animations, doing damage, all of that stuff. That's where it's going to reside, in this fighter class. So let's go ahead and add this onto the player while we're at it. So I'll go into the player prefab and add a component called fighter. So now we've got a fighter, a mover, and a player controller all on this player. So that seems to be making somewhat some sense. Now we have to enable it to actually click on this object. How is it going to know that this is an object that we can attack? Well, for that we're going to create another script, also in combat, also in the combat namespace, because it's all to do with that combat behavior. And it's going to be, what are we going to call it? The combat target, perhaps, for now, because the important thing is that it just allows us to target things for combat. So I'm going to create a mono behavior again, and I'm going to stick this in a namespace called rpg.combat. You see this time it's auto-completing it because it's not the first time I've created this namespace, and then I'll put the combat target in there, which at the moment is just going to have no functionality at all. It's going to serve as a placeholder for us to know that this thing, this capsule, this enemy capsule, is something we can attack. So I'm going to add the component. It's going to be the combat target again, and I'm going to apply that to the enemy prefab as well. So added component, apply to prefab. Obviously you could open up the prefab editor and do that directly that way as well. Okay, so enough of that. We want to actually get on with doing something. This player controller needs to call to that fighter method in order for us to actually start the whole process of attacking that enemy. How are we going to do that? Well, at the moment the player controller is only doing, well, it's only doing movement-based stuff. In fact, we can make that really explicit by selecting everything that's in the update, and you can either hit the light bulb or you can hit control period, and it'll give us some options here. In this case, it's extract method, and that's what we want to do. I want to extract it into new method, it calls it new method, and I can rename that with F2, and I'm going to call it interact with movement, like so. So we've got a new method. In update, every update, we interact with movement, which involves getting the cursor and moving, getting whether the mouse button is down and moving to the cursor, basically. What we want to do is add in a new function in here, which is going to be interact with combat, like so. Obviously that's not created yet, so again with the little light bulb or with control dot, control period, you can generate the method automatically. And there you go, we've got a interact with combat. Now what is it we want to do here at this point? Well, I think what we want to do is raycast, but there is a little bit of a thing that we should look out for. For example, what if I'm playing, let's just try and set up a scenario here, where if I take this capsule and I put him a little bit behind the tree so that he's just about poking out. See if I can see that in the game. If I move over, it's not working because of my code in here, the interact with combat. This shouldn't throw anything if I want it to actually be able to run. Let's try that again. So I'm going to move over here. The tree will be able to obscure where I'm going, but I can still click to move, as you can see. So what we want to do is, even if there's something obscuring it, when we click on the capsule, it should attack it, because that's a high priority, right? Even if we can't see it, we want to be able to attack it. So how does that work? Because currently our raycast will return the first thing it hits from the camera. Well, one way of doing this is using a very similar function to the physics raycast called physics. Hold on, if I can type correctly, physics.raycast all. Now, this signature, as it says here, there's a few of them, there's 8 of them. You can do raycast all with vectors, but there is one that takes in a ray, I think just a ray, this one, the last one, takes in just a ray, very much the same as our physics raycast, but instead of having an out parameter for the hit result, what it does have is a list of hit results. So it returns all the things it hit. It just carries on going. It's like a bullet with a lot of strength that just passes through all of its targets and it's a very, it's an accountant bullet because it keeps track of who it hit as it went along. So the idea here is we have this raycast hit result. So let's do raycast hit array is what's going to be coming out of this, and then we'll just call this the hits. And then what we were passing in is the ray. Now we have to produce the ray basically in exactly the same way as we were doing in move to cursor. So because it's exactly the same and I'd like it to be exactly the same, I'm going to select the code that generates the ray and I'm going to extract it. So extract method, like so. And it has automatically, notice this is quite cool, it has automatically called it getRay because I think it's done that, but either based on the type or based on the name of the variable. But that's pretty cool and quite clever. I just want to tweak it a little bit. Rather than calling it getRay, I'm going to call it the getMouseRay. So it's obvious that it's the ray based on the mouse position. And the other little tweak we can do now, because this variable is practically just noise now, is if I select the variable and hit Control dot again, you can see that there's quite a lot that Visual Studio Code can do for us. It is inline this temporary, asking me to inline the temporary variable, which basically means it goes and replaces the variable in that raycast, which is pretty cool, pretty handy. And now that means that I can do this get mouse ray in our raycast all, and the result coming back from it after I put my semicolon on the end of the line is going to be a list of hits. And I can for each loop over those. So if you've not come across a for each loop before, you probably have come across a for each loop, I hope. If you haven't, it's pretty straightforward. It is a loop, very much like a for loop, any sort of loop, where it will execute the code in the block for every item in a list of items. So we're going to do a for each of a raycast hit. I'm going to call that single item a hit in the collection, which is going to be the hits. So for each hit in hits, it makes quite a lot of sense. This code block is going to run for each hit. So this is the place where we can do something with those hits. We can see whether we have hit a combat component, and if so, we can start attacking it. So this is where I recommend you read up on the documentation for raycast hit to see how you can get hold of the object that was hit. Maybe you can get hold of the game object. Maybe you can get hold of a component on the game object, which will allow you to then get hold of the combat component, something along those lines. And the end game is going to be this challenge to call the attack function on our fighter component. So you are going to find the results that have a combat target. So you're going to need to do a get component, check whether it has a combat target, that sort of thing. Then you're going to call attack function in fighter. So you've got fighter as a sibling component. Call attack function on that. And test it out. See if you can click on target and get the right log message. Hit pause and try it out. Okay. So the key here is that when you look at the properties that come back from hit, you can do this with the autocomplete, or you can do this by looking at the documentation. There are a few things. You've got the rigid body component. You could use that. You could use the collider component. It's I think what I'm going to go and use because you might not have a rigid body, basically. Or the transform. The transform would work just as well. The transform of the rigid body or collider that was hit. So because that works with either a rigid body or a collider, I'm kind of inclined to go with hit.transform. And then we can do a get component, because transform is a component, remember, and you can do get component on any component, which gets all the siblings. Or looks through all the siblings. And then what we're going to do is look for the combat target. Notice this isn't coming up, even if I type it out in full. That's not just slow autocomplete. Let me just give you a mini challenge to figure out why do you think that's not coming up. Just have a think about it. And you might have guessed it. Basically, we haven't included the combat namespace. So we are going to have to also include, as well as movement, the combat namespace. You can see this is getting quite heavy. The player controller is already getting many dependencies, and you can think ahead a little bit if we had dialogue and so on being spawned this way. It's going to depend on a lot of things. Don't worry, we'll sort that out later down the line. We won't sort it out just now. So what we're going to have back here is a combat transform, or target, sorry. And I'm just going to call it the target, like so. And what we need to do is check if it's null. So if the target is null, what I'm going to do is continue. What does continue do? It might be a keyword you've never seen before. You might have seen return, you might have seen break. Maybe you haven't seen either of that. Well, either break, or you've probably seen return. Continue is basically a keyword that says, carry on with this loop. Skip the rest of this body of the loop and go on to the next item, basically. Which means that everything after this line in the for body will inherently be not null, because if it was null, it would have carried on with the next iteration of the loop. So it's another way of doing a guard for inside a for loop. So what we're going to do here is we're going to do a target. We're not actually going to use target here. That's a good point. That we just did this to make sure we're filtering and making sure this hit result is only on something that was a combat target. So what I want to do now is, if we have our input.get mouse button, like so, then what we're going to do, I'll get mouse button down, in fact, because I don't want to be able to hold down. I don't want to hold down to attack. I want to click and start the attacking process. So if the mouse button 0 is down, then what we're going to do is we are going to get our sibling component called the fighter, and we're going to call attack on that, like so. And just one more thing, I think what we can do here is, in that fighter component, we can have the combat target as an argument to it. We're not doing much with it at the moment, but that's okay. And we can just pass that in for later. Don't worry if you didn't do that. I'm just thinking ahead that we're going to need to know who we are actually trying to attack when we start the attacking process. So let's try it out. Hit play. And if I hit the capsule, there you go. Take that, you short squat peasant. Only when I hit the capsule. So I click multiple times, it comes up multiple times. Great. So we've got our raycasting happening onto a component, and we're being able to detect that it's happening to a component, and then we're calling a function on our fighter method, which is the starting point of really getting the ball rolling here with attacking. So I'll see you in the next lecture, where we'll be progressing this fighting system. Welcome back. In this video, we are going to be having some priority for our actions. Obviously, we can move around if that is the only thing we can do, but if we're hovering over something we can attack, we shouldn't be acting like we need to move to it. We should just be doing our attack procedure. So if you look in the console, I'm clicking, it's doing my attack procedure, but it's fundamentally not also moving to that point. In the long run, this is going to allow us to also put what I'm calling cursor affordance, which is a cursor that is either something that shows that to the player that it can attack, or that it can move, or that it can't do anything with this particular object. And that's very useful in UI, because when I'm hovering over something, it allows the player to discover that you're allowed to attack this thing, or that you're allowed to talk with that thing. And so that's going to be quite important in the long run. We're not doing that in this lecture, but we are laying the foundations for it. So let's dive in and see how that's done. So you may have noticed some slightly undesirable behavior when we try to attack this capsule, is that we're moving right to it. So clearly we are both doing an attack action and a movement action, which is not really the correct thing to do. If you're attacking, you're attacking. If you're moving, you're moving. And those are two different things. So we need to sort out our priorities. Basically, if I've clicked on something that I need to attack, then I don't move. And if I click on something that I need to move, then I don't attack, and vice versa. Well, that is vice versa. So how do we get something like that to work? So I think the best way to do this is to have our interact with combat tell us whether or not it succeeded. And if it did succeed in interacting with combat, then we don't go on to interact with movement. If, however, we didn't succeed with combat, then we do go on to movement. So that's the priority, right? If you click on something to attack, then you should attack. Otherwise, you could move there. Obviously, the other way around doesn't make much sense, because you can move practically anywhere, and if you just move to the enemy rather than attacked it, that's kind of getting your priorities messed up. So how are we going to change our code here? Well, firstly, I want to return a Boolean value from interact with combat. I'm going to show you how this works in here. So this is going to return a Boolean, and we're going to use that in our update. So we're going to say if interact with combat, so if we have interacted with combat, then I'm going to return early. So this is very much like our continue. It skips over the rest of this body and exits the update. And that means it won't interact with movement, which is pretty much what we want it to do. So how's this going to work? We need to, you can see it's complaining here because we're not actually returning a Boolean from our interact with combat. So I think the clear time that we have successfully interacted with combat is going to be down here, either when we are inside this if get mouse button down, we might return true here. So we're saying, oh, I clicked it. Yep, I interacted correctly with combat. But actually what I'm going to do is take this outside of the if statement. Why is that? Because even if we have our mouse not down this frame, but we're hovering, just hovering over that combat target, we actually don't want to do any kind of interaction with movement. Why is that? Because later on down the line, what we're going to want to do is provide some cursor affordance, which is basically going to say, if I can interact with movement, then I've got to show a combat cursor. Otherwise, I'm going to show a movement cursor. So that's just kind of laying the foundations for that. We are interacting with combat, even if we're just hovering over it, even if we haven't clicked. So that's why I'm returning true outside of the if statement. And otherwise, basically, if we get to the end of this for loop and we still haven't returned true, if we still haven't exited the for loop, then that's the time when we should return false. So we've exited the for loop and we just return false because we didn't find any combat targets to interact with. So we just return and then we interact with movement. So if we have a go now, see if this is going to give us the behavior that we want. I'm going to go ahead and hit play. After it finishes compiling, takes a little while sometimes. I'll click on the capsule and you notice, nope, it's not going to move there. But if I click anywhere else, I can still move. So that's pretty much the behavior we want. When we're clicking on the capsule, it is not doing combat. Now, there are situations where you might not be able to move to where you click. So I would like you to do a similar thing that we just did with interact with combat, and do it for movement as well. So the way we're going to test this is I'm going to have a print statement going nothing to do right there. And that's going to be at the end of our update, and if we get it all right, then when you go to the edge of the world, which is a place where there won't be anything to interact with, the ray will go through nothing and you won't be able to move there, then you should be able to, when hovering over the edge of the world, over the terrain, not over the terrain rather, then it is going to print nothing to do. So that's your challenge, to get that print to run. You're going to replicate the procedure that I followed for combat, and when you get to the edge of the world, it should print. And not only when you click, but also when you hover over. If we wanted to have the same behavior as combat, that's what it should do. So pause the video and have a go at this. Okay, welcome back. So let's give this a shot. So the first thing is to put this if statement in here. So if movement returns true, then we're going to return because we are able to, we're hovering over something that is movable. Obviously I haven't changed this to Boolean just yet. So interact with movement wasn't Boolean, now it's Boolean. And you'll notice there's going to be a problem with doing the exact same procedure, because I could choose, if the mouse button down, then true, otherwise false. But that's not going to work when it's just hovering, is it? So we need to kind of flip things around a little bit. You notice how we've got the get mouse button down here on the outside. It's not even doing a raycast if we're not clicking. We need to flip that around, especially if we're going to want cursor affordance. So what I'm going to do is I'm going to take this if statement, in fact just the if condition, and copy that. And then what we're going to do is inside our move to cursor, we're getting that component, the mover component, and moving to it. That's if we've got a hit. So I'm going to do my if in here instead. So it's going to be if get mouse button down. So if the mouse button is currently down, not the first frame, but currently down, then we are going to move to that point. But either way, we are going to return true. Now you notice this move to cursor is no longer correctly named. Really, it's the whole thing is just interact with movement. So I'm going to pull that all into one method. So interact with movement now does a raycast every frame, and it will return true if it could interact with movement. That's going to give us the cursor affordance in the long run, and right now it's not. By the way, by affordance, I mean, giving a hint to the user that what can be done. So if there's a walking cursor, they know that they can walk there. If it is an attack cursor, they know they can attack there. That's what we mean in user interface design by affordance. So the interact with movement now returns a boolean, but not everywhere. If you hover over it, it's saying not all code paths return a value, which is a fancy way of saying that basically if I ran through all of this and this if statement was false, I wouldn't have a return value at the end of it. It wouldn't know whether it was true or false. So I'm going to return false at this stage. So if has hit, we are going to do get mouse button and return true. So if it finds something, we return true. If it doesn't find anything, we return false. So that should pretty much do the trick. Let's move our character a little bit towards the edge of the world. So I'm going to zoom out, get to the player. I'm going to stick him near the edge of the world over here. In fact, it's going to be quite troublesome if you want to move the player around. Sometimes it's easier just to delete the player as long as you don't have any modifications to the prefab, which you shouldn't because you should try and apply them back as much as possible. And we're going to go to the game, characters, easy to find because of our new layout, and we can drag that character right onto the edge of the world. And if we go ahead and hit play, it's going to complain because the follow camera is not set up to point at the player. And I hit play. Now we're on the edge of the world, and if I hover over the edge of the world, you can see it's printing log messages about there being nothing to do. So clear, and I'm over the terrain, and nothing's happening. Hover over the edge of the world, and I didn't have it focused. I don't actually have to click to have it coming up, but I just didn't have the game viewport focused. But if I go over the edge of the world, it's printing nothing to do. So we know that it is getting to this stage, this print statement in the code. So I'm happy with that, which means that later on, when we are adding cursor affordances, we can put something like a no action is possible here kind of thing. For now, I'm going to delete that print statement, though, because we've got the idea. You've kind of cemented it by doing it yourself with this interact with movement. So I'm happy. Let's move on to the next lecture. Hello, welcome. In this lecture, we are going to be implementing a move within range functionality. So if I click on our target, we move within the specified range over in the fighter of 2 meters away of that target. So we're 2 meters away from the center of the target, and he stops. That's the idea. That's what we're going to implement in this lecture. Let's dive in and see how. So at the end of the last lecture, we left the player standing here at the end of the world. Now, this is obviously not where we want him because we want to be able to play with our combat. So I'm going to drag my player near the enemy and hook up the follow camera. At some point we can do something more automatic with that, but for now I think that's good. Let's go ahead and hit play and see where we're at. I click on the enemy and nothing's happening. Oh, by the way, I'm scaled in here for some reason, don't know why. So it doesn't move towards the enemy. That's the first thing that seems wrong to me. I can't attack from this distance. I should move towards the enemy when I click on him. So let's try that out. If I go over to my player controller, no, not my player controller, the fighter script, then I've got this attack that is currently happening here. And what I would like it to do is actually use this to move towards the target. So we want to move in range, but we also want to stop once we've got within range. So that's going to mean we're going to need to have some concept of the thing we're targeting so we can check whether we got within range, and also the enemy might be moving around, so we might need to keep moving to a different location. It's no good doing basically a move to in this attack because we might need to change that every frame. So because the enemy is a moving target, I'm going to create an update function, and that's where we're going to do our movement instead. So I'm going to have a target private variable. It's going to be a combat target. No, in fact, I'm going to just make it a transform because that way we can very easily get hold of the position and location. And this is going to be the target. Currently not set to anything. which means that we need to be able to set it, and that we can do in attack. So if we have been told to attack this target, then we're going to do, probably easier if I call it one of them combat target, I think, like so. So combat target, I'm going to take the transform of and store it there. So now at any update in any frame, the fighter knows whether it needs to attack or not because it has a target, basically. So we can do an if statement here saying that the target is not null. And if it's not null, then we want to move towards it, basically. So I'm going to get hold of the get component mover. Now, I don't have the mover in here because I'm not using the right namespace. So if I do using rpg.movement, it's going to give me access to the mover script, like so. And then I can call move to. And the place I want to move is to the target's position. I want to move in that direction. Now, if we go ahead and hit play now, and were to click on the target, we move directly to the target and stop right in the middle of him, which isn't really what we want to do. We want to stop at a good range away from the target. So what I'm going to do is add a serialized field that's going to be our range for now. We're going to do things with weapon configs at some point, but not just yet. So it's going to be a float, and we'll call this the weapon range, like so, and I'm just going to set that at about 2 meters for now. And this is going to be your challenge to see if you can stop him moving when he gets within that range. But first let me show you how we can stop a navmesh agent, because at the moment our navmesh agent, if we head over into the mover CS script, is setting a destination and it's moving no matter what. It's never stopping. So I'm going to create a public method, void called stop, and it's not going to have to take any arguments. And how can we stop a navmesh agent? Well, what we're going to do, in fact we're referencing this in quite a few places. I'd like to make this into something that we created on, we get a reference to on start. So it's going to be a navmesh agent private variable, which is going to be the reference to the navmesh agent, calling it what it is, and then we'll have a start function which we're going to get the component with. So navmesh agent equals the get component navmesh agent, like so, which means that now that we're going to use it in more places, we don't have to keep getting the component all the time, which is just a bit easier for us to read. So the navmesh agent now in stop. How do we stop a navmesh agent? You could take a guess if you like and pause the video, see what you can do here. And you may or may not have found it, but the property is called isStopped. And you can actually, as well as referencing this property, as well as reading from it, you can set it. So I can say isStopped equals true. Now, obviously, this needs a counterpart because we need to be able to restart this. So maybe when we call move to, we are going to start it. So it's going to be isStopped equals true unless I have said move to, in which case it's going to start moving. So I think that's pretty clear. So why don't we take it on as a challenge to stop within range, check how far we are from the target, and if that is less than the range, then stop. You might need to do a little bit of searching around for seeing how we can find the distance between two vectors. You might do a little Google search and you might find some useful snippets there and be able to understand them. So I do encourage you to do a little bit of your own looking up there. Pause the video and have a go. Okay, so we're going to dive in, and over in my fighter, the first thing I want to do is check whether basically we are in range. So we're going to need a boolean is in range, like so. And what are we going to do? Well, we're going to find the distance between the target position and our current position. So it's going to be vector3 dot distance. It's a handy little function that we can use to get the distance between two vectors. So I can do a transform dot position, which is my own position, and I can do the target dot position, and we can check that that is less than the weapon range, then we are in range, like so. So we are now in range, and we can use that in this if statement. So we're going to say if the target is not null and it is in range, move 2. Otherwise, if we have no target and we're not in range, in fact, is that going to work? Well, we'll see and we'll sort it out if it doesn't. Else, then we are going to try and stop the mover. So again, we've used this mover twice now. We might want to think about saving it in the start, but I'm not going to do that in this lecture. Move 2, and we're going to stop if we either don't have a target or it is not in range. So let's go and have a look. Hit play. And click on the target. I must be in range. Oh, doesn't quite seem to be working. That'll be because I've got this the wrong way around. What we want to say is if it is not in range, then move 2. Otherwise, stop, obviously. So let's try that again. And clicking the target, there you go. It moves within range and stops 2 meters away. And we can just make ourselves happy about that. If we go to our player, you see at the moment there's a bizarre behavior where he kind of always tries to run back to that target because we never unset it. We're going to worry about that later. But if I change the weapon range to 5, then I try and by holding down come away, then he stops further away depending on what that value is in the script. So hopefully you're happy that he is now moving within range as we set out to do. And I'll see you in the next lecture where we'll try and refine some of that behavior, such as why we can't move away from the target once we've set it. See you there. Hello, welcome. In this lecture, we are going to be solving the cancelling issue. So when we go to attack our enemy, we walk up to it, start attacking it. Let me show you that we're still in this attacking behavior, because if I click on my enemy and move it around, I'm going to follow it around and keep bashing it. Well, I'm not bashing it yet, but I could be. But I can now cancel. So if I click off with movement to somewhere else, then I run away and I stop trying to attack. And no matter what I do with this enemy, move it around, I'm not going to be following it anymore. So let's dive in and see how we can get this kind of cancelling behavior. So the behavior we're seeing at the moment is that if I go ahead and attack the combat capsule, try and move away, then I basically have to hold down to move away, because otherwise it keeps trying to attack. The reason for this, as we saw that behavior in the last lecture, but the reason we didn't see, the reason is that whenever we have a target, we are going to be trying to do our attacking behavior in update. And this isn't really what we want. What we want is to be able to, at some point, cancel this target, because it's set one time, and so it never gets unset. So let's create another public method in here, public void cancel. And public void cancel is, all it's going to do is set that target to null. Now, I'm going to leave that as a challenge to you now to see if you can figure out how to get it to stop attacking when we move. So remember that combat triggers movement as well. So you're going to have to, if you want to, I suggest you do this from the movement script. The movement script cancels the combat when you start moving. But remember that combat also calls on the movement script. So you need to differentiate between the movement that is kind of an action. So you are clicking and it's like that's the movement action and it should take priority over other actions like fighting. And the movement that is not an action that is being used kind of as a library from the combat. So think about how you might differentiate those two and make it so that your combat is cancelled when you move as an action. Pause the video and have a go. Okay, welcome back. So let's give it a shot. In the mover, what I'm going to do is I'm going to introduce a new method, public void start move action, and it's going to take the same input, the destination, as our move to. Now, move to is something that we're going to be kind of doing every frame, whereas the start move action is going to be something that we set off when we click. So I'm going to just from there call to move destination. Now at the moment this isn't doing anything different, so why did we bother? Why have we introduced this complexity of another function? Well, because if we go over into Player Controller, into the Interact with Movement script, and have a look at line 42 here, then we want to replace that with the Start Action call instead. And that means that now we have a distinction between when we've got an action starting and when we're just calling move to. If we didn't do this, you'd have seen an interesting problem. But first, let's try this. Get component combat, like so. No, not combat, fighter. There we go. And we're going to call on that. But first, I'm going to add a using by selecting the fighter type and, again, hitting Control period on Windows, check out on the Mac side what you've got to do, and then selecting the first option of adding that using statement. I'm going to call dot, and we're going to call cancel. So we're cancelling fighting before we even start moving all the time. And that should be okay. Now, what was I? So that's the difference, basically. When we start a move action, we cancel fighting. Otherwise, we don't, which is just as well because the fighter calls that. So if we were, every time we were fighting, we cancelled fighting, it wouldn't make any sense. So that's what we're doing. But notice I did something a little naughty there. I did a using statement. I included a using statement just like that, snapping my fingers and automatically added this. This is a bit dangerous doing it like that because now what we've got is a circular dependency. Because movement now depends on combat, and combat, as we already knew, depends on movement, and we know circular dependencies are nasty. So we're going to be fixing that in the next video. For now, we'll deal with it, but just so you know. Okay, so this should do the trick. Let's hop over into the game and see what we got. We hit play. And go up to the capsule and go away from the capsule, and indeed I start to move, which is good. But notice there is a bit of an issue here. Down here I've got this null reference thing. So let's see if we can fix that null reference. What's it referring to? It is referring to, this is in range. We're trying to calculate it with the target position, but if we don't have a target, because we cancelled it for example, this isn't going to work. So one way that we can solve this is by moving this into a method. So I can do this with the little light bulb, extract a method, it's automatically named it really well, and I can even inline this variable, meaning that I replace the one usage of this variable with the actual calculation that that variable is doing. Now, what's going to happen here is we've got something called a shortcut operator, or short circuit operator in fact. This double AND operator. And the reason this is a short circuit operator is because if it already knows the answer for the whole expression, this whole if statement, if it already knows it from having just evaluated this first bit, it won't even bother to evaluate the second bit. So, for example, if our target is indeed null, then we know that this thing here, target not null, is going to be false. Because the AND operator requires both things to be true for it to be true, it already knows that if this first thing is false, then the whole thing must be false. So it doesn't even bother to call the function getIsInRange, which is perfect, because if we did call getIsInRange when we've got target null, then we're going to get that null reference error. So hopefully that should fix our null reference error. Let's give it a shot, hit play, and go ahead up to the combat and click away. But now we have a different issue, which is it only moves when we're holding down the mouse. Why is that? Why is it only moving when we hold down the mouse? Reason being is that when we don't have a target, we always call stop. Even if, well, basically if we don't have a target, we're always calling stop, which is not great for the mover, because if we're trying to do a move action and it's currently basically constantly telling it every frame to stop, then we don't really get anywhere. And the fact that we get anywhere by holding is a bit of a fluke, to be honest. So if we go into update and say, look, if we don't have a target, so if target is null, then we aren't going to do any of this behavior at all, so we'll return early. And that would also have solved our getIsInRange problem, but, you know, extracting into a method's not a bad thing anyway. So we've got, if the target's null, return early. We're not going to stop or move if we are not essentially fighting. But if we are fighting, then we've got two options. We're either in range, in which case we stop moving and we'll probably play some attack animations, or we're not in range and we're going to move towards our target. So hopefully this brings us to a more solid behavior. Click on the target, moves to it. Click away from the target, moves away from it. And that seems to be working quite nicely. So now the only problem we've got is that circular dependency, and we're going to look at that in the next lecture. So I will see you there. Hello and welcome. In this lecture, we're going to be cutting our dependency knot by introducing something called an action scheduler. The idea will be that when you are attacking something, it will cancel the last thing, which was movement. And if I am moving away, then it will cancel the fighting. So this is all being done via a scheduler. I can go backwards and forwards, cancelling these things. Attacking things will continue to attack things and so on. So this is the idea. We're going to be using an action scheduler to tell us what should be cancelled, and to do that in a way where not everything has to depend on everything else. So we don't have to have combat depend on fighting and movement depending on fighting, and we don't have to have movement depend on maybe any other actions that we could do, such as picking up inventory items. All of that can now be handled through the scheduler. So let's dive in and see how to build it. So we've got this nasty dependency cycle at the moment where combat depends on movement to move. That's fine. But vice versa, we've got movement depending on combat to cancel. Not so great. I think we can do something about that. So how do you go about breaking dependency cycles? Well, you think about whether you need to have a direct reference to this thing, or whether you can do it via something else that you can both mutually depend on. So that's what we're going to do. Add in a mutual dependency which can break these knots. And that's going to be a scheduler, because we've been talking about these actions, a movement action, a combat or a fighting action. And the scheduler would be the perfect place to do that. So when you start a movement action, you say, hey, scheduler, I'm starting a movement action. And then when you start a fighting action, you say, hey, scheduler, I'm starting a fighting action. And it can say, hey, I know that movement was already running, so I need to tell movement to stop before I can tell you to go. And that's what we're going to do with this introduction of a scheduler. Now, it means that the control flow is still going to be going the same way. By that I mean the movement is still going to be essentially calling to combat, but it's not going to know anything about combat in the process. It's going to just talk to the scheduler, and the scheduler is going to talk to combat. And there are going to be, in the next lecture, I'll tell you about something that allows us to do execution the opposite way to the dependency. So what I'm saying is that instead of having to have the scheduler depend on combat to call a function in combat, we can have combat depend on scheduler so that scheduler calls to combat. Very strange, but we'll have a look at how that works in the next lecture. So don't worry about it just yet. So what we want to do is introduce a new class called a scheduler. So I'm going to go to core, this is the right place for it I think, called action scheduler.cs, and I'm going to make a mono behavior. Why core? Because we want it to be at the base of things. We want it to be depended upon. It's a lower level dependency, a lower layer, as we were talking about with namespaces before. So let's add a namespace. This is getting quite routine for us now. We are namespace core action scheduler. What should its public API be? Let's think about that. Well, I'm going to basically start an action is going to be what I'm telling it to do. What should it take? Well, let's have a little think about that. We basically want to cancel the mover when the combat starts, when fighter starts, and we want to cancel fighter when movement starts. So maybe a reference to the mono behavior itself would be the action. So mono behavior is going to be our action. So let's just take a second, because I think we just hit on a very interesting topic here, which is a core to a lot of object-oriented design and object-oriented programming in general, and it's called the substitution principle. The idea is that when you inherit from something in object-oriented programming, you have to behave exactly like that thing. So, for example, say we had a missile class, and a missile class is something that can be pointed in a direction and launched, right? So that means that if my bullet derives from missile, then it must be able to be pointed in a direction and launched. And you can say that's true of arrow, you can say it's true of rocket. If all these things derive from missile, then they must be able to be pointed in a direction and launched. So that means that the substitution principle says, if I have a function that takes in a missile as its argument, for example, because it wants to launch it, for example, then what I should be able to do is actually give it a bullet, or give it an arrow, or give it a rocket. And it won't know that it's an arrow, rocket, or bullet, but it can treat it like a missile, and it will just do its job without it having to know which of the subtypes it is. That's the substitution principle. You can always substitute a derived type, a type that inherits from the parent type, instead of the parent type. So basically, we can replace a bullet, we can pass a bullet to a function instead of a missile. So why does that help us? Because in our case, what we've got as the parent class is the mono behavior, and the mono behavior we inherit in mover and we inherit it in fighter. So this means, by the substitution principle, that our mono behavior action can actually be passed a mover or a fighter. In fact, it could also be passed a player controller and so on and so forth, which isn't quite right, but we're going to fix that later on in a follow-up lecture, not in this lecture. So with that said, what are we trying to achieve with this substitution of mono behavior? Well, what we want to be able to do is cancel this action at the right time. So I'm actually going to leave that as a challenge to you folks to get cancel printing. Because ideally what we'd actually want to do is call cancel on the action mono behavior. But because mono behavior doesn't have a cancel function, we don't know for sure that the exact mono behavior we're being passed in actually has one. To know that for sure, we're going to need interfaces, which are the subject of the next lecture. So what I'm going to get you to do just for now is, instead of calling the function, just print that you are going to cancel that action. That's basically what I want. So we should start off by calling start action from both the mover and the fighter in the appropriate places when you are starting the action. Then we should cancel the previous action. So I would expect to see a log message at this point. So if you started moving after you'd just been fighting, I would expect to see that the mover has been cancelled. And then it shouldn't cancel itself. So if you start moving again when you've already started moving, it shouldn't print any cancellation. So pause the video and have a go at setting up this mono behavior. Remember, you need to add it to your player prefab as well. Okay, welcome back. Let's get that going. So what we're going to need to do is keep a reference to the last action that was running. So it's going to be mono behavior, current action, and it starts off as null. And then what we're going to do is we're going to set that current action in start action, like so. Now that's all well and good, but we need to print out when we want to cancel. When should that be? So we need to do it before we've overwritten it. So let's do a print, then cancelling, and then I can just add on the current action, like so. Let's put some spaces between here for pretties and coding consistency, and let's see what that does. First of all, I'm going to need to actually call start action. So maybe you've missed this step, but we do obviously need to start the action from both mover and the fighter. So where's the logical place to do it in fighter? When we start the attack. So I'm going to do a get components of type action scheduler, and we're going to call start action with this. Now I'm going to need to include the core namespace for this, like that, and that will work. And then in mover we want to need to do the same thing. In starting the move action, we need to call start action, and we need to include that namespace. So if I go in to play this, what's going to happen? We're going to need to, let's see, go into player, add a component to player called the action scheduler. Otherwise we'll get null references. And we hit play. And if I, notice this. We seem to be calling cancelling all the time. That's one thing. But also that first time, you see that first action didn't cancel anything. That's because we had a null pointer. So we don't want that. So we're going to do if current action is not equal to null, then we can print cancelling. So that's that first thing taken care of. The second thing is that we're cancelling when the mover is trying to start them after the mover. So we don't want that to happen. So if the current action is already equal to the action, we don't need to take any kind of action. We don't need to set it, we don't need to cancel, because it's already running. So we can just leave it at that. Let's try that out. I'm just going to restart, play. Moving around does nothing because we started off with none, there was nothing to cancel. So this was the first action, and because it's all movement, all these calls to action are going to be just returning because we're already moving. But if I click on the enemy, there you go, it's cancelling the mover. And if I click away, then it's cancelling the fighter, and vice versa. I can keep doing that as long as I like. Okay, so that's got us set up with the right kind of cancelling flow. In the next video, we're going to look at how we can actually call a cancel function on this mono behavior without having to cast it and say, hey, is it a mover, in which case call this function. Hey, is it a fighter, in which case call this function. Because that's just a pain in the bum, and introduces a lot of dependencies, because then our action scheduler is going to be depending on the combat, and it's going to be depending on the movement, and that's going to create more circular dependencies. So we don't want that. So let's have a look at how we can attain that kind of behavior in the next lecture. See you there. Hello and welcome. In this lecture we're going to get it back to working so that we can combat, we can cancel our combat, and all of that good stuff. And we're going to be doing this using a new language feature you may not have come across before called the interface. We're going to be implementing an interface and figuring out how that helps us to call from the action scheduler to the mover and fighter, depending on which one it is, without having to introduce more dependency cycles. So this is quite cool, quite interesting. Let's dive in and see how it's done. So we're in a bit of a conundrum here where we've got printing cancellation working correctly, but it can't possibly call the functions of cancel on mover and fighter because they're of different types. If I were to change this mono behavior to fighter, then it wouldn't work for mover. If I changed it to mover, then it wouldn't work for fighter. So one way I could try and solve this is by casting. I could say in here, for example, if, something along the lines of, if it's a fighter type, then we're going to do something. If it's a mover, then we're going to call a different function. But there is a problem with this. At the moment, we've got our dependencies set up this way, but if I were to try and call to movement and combat, I would be also creating dependencies from the scheduler down to the movement and combat modules, which means that we've got dependency cycles again, which is absolutely no good whatsoever. So what we can do to solve this problem is introduce something called an interface to invert the dependencies, where we had dependencies that would go down from scheduler to movement, so we could call from scheduler to movement. We can invert these dependencies, so that instead there's a dependency going from movement to the scheduler, to the I action, in fact. What is an I action? It is an interface. It is a contract between the implementer of the contract, this would be movement and combat are the implementers, and the caller of the contract, which is going to be the scheduler, which is going to depend on I action. So how does an interface work? Let's have a look. I'm going to create a new file for our interface and call it iAction, and we'll see why in a sec. I'm also going to put it in a namespace of rpg.core, and then we can use the interface syntax, which I've got a snippet for. The Unity snippet will automatically add the name for me. And it's very much like a class, except that instead of using the keyword class, we use the keyword interface. Now, what does that mean? Well, it is a contract, so we can say that anything that implements this interface, that's movement and combat, has to have a certain method. So I can say that it needs to have void cancel, for example. Notice I don't have to say that it's public. Everything in an interface is public because there is no implementation in the interface. You can't have any bodies to these cancel, for example. Notice I put a semicolon on the end. I can't actually put any kind of implementation in here. I can't put any variables. I can't put anything like that. It can only be methods or properties, things that can be implemented in other classes. So it is just a contract. There's nothing more to it. It doesn't actually implement anything itself. So the point of this is that now, when I have this iAction and I've told it that it must implement cancel, well, I can go over to the action scheduler and say, instead of a mono behavior, let's take in this cool iAction thing. And I can, because I know that anything that implements iAction has to implement cancel, I can call action.cancel. The eagle-eyed among you might notice this actually introduces a bug. What I wanted to do was call current action.cancel, and I will correct that later on in the video, but just so this doesn't trip you up when you come to do the challenge, that's what you need to change. Now let me demonstrate this. This is how you would implement iAction. You go over to something that you want to implement iAction. For example, we go to the mover. And we know that we want it to implement iAction because it's giving us this error here that if I try and pass in this to start action, it's saying, hey, I can't convert mover into an iAction, which just makes sense because it doesn't implement that interface. So I can get it to implement the interface to obey the contract. And you can see by basically putting comma and then the interface after the things that are inherited at the top here. So notice you can't inherit from more than one class, but you can inherit from as many interfaces as you like. Now it's saying to me the error is mover does not implement interface member cancel. So what that's saying is I need to have a function here, a public function called cancel. Right, so that should be public void cancel. It has to be the same in all respects, the same number of arguments, the same type of the arguments, the same return value. And once I've done that, notice that error has gone away because now mover implements iAction, and that means I can safely pass it into the start action because then in start action I can treat it like a start action. I can call cancel. I know it must have a cancel implementation. This is basically why it allows us to invert the dependencies. When the scheduler wants to call cancel on iAction, it actually gets redirected to the movement, to the mover's implementation of cancel. If instead it was an instance of combat, if it was an instance of fighter instead of movement, then what we would get is it would call cancel on the fighter instead. So that's what I'm going to want you to do, is to implement the interface on both the fighter and the mover. The moving should stop attacking, very much as we've had it doing before. But I'd also like you to have a go to see if you are actually able to cancel movement by attacking. Now this presents a bit of a problem because by default attacking does some movement. So if you clicked on an enemy while you were moving somewhere else, it would start moving towards that enemy, whether or not it has cancelled the mover. So one way you can check that the movement is actually being cancelled when you start an attack action would be to comment out this block of code here so that the combat action does no movement. We'd only do this temporarily, so that then what you'd be able to see is that if you're moving along the ground towards a certain location and you click on an enemy, the movement is disabled for the fighter, so it won't do any movement, but it should cancel the mover. That's the behavior we want to see. And then you can uncomment the code again and everything should work again. You should then cancel, stop in its tracks, but then move towards the target. I'm just saying to comment out this code so that you can test this independently to see that the cancel is coming through and working as you'd expect. If you find you're struggling with the second part of the challenge, do attempt the first part first and see how far you get with the second part. So pause the video and have a go if you can wrap your head around how these interfaces are working and try and implement that knowledge through this challenge. Okay, welcome back. Hopefully you didn't find that too tricky. Hopefully you've got the right building blocks in place. If not, it's my fault and I'm sorry. Hopefully you will get it from the solution. So first of all, we want to implement, let's see, the iAction mover. We've got that, and we've got cancel. What should cancel do? Well, I think it should probably be synonymous with stop. So I'm going to actually remove this cancel function, and I'm going to just rename stop to be called cancel instead, which should rename it across the project, including where it's called in fighter. Now in fighter, I want to implement iAction as well. There we go, like so. And you notice that we already have a cancel, so I don't have to implement it, and I think it does the right thing. And if I go over to the mover, there's one thing that we can now remove, is this fighter.cancel. We don't want it doing that anymore. We want it to be entirely via the action scheduler. So I can remove this dependency on combat, which removes our circular dependency, so we're happy. Let's go over and hit play in Unity, see if I missed any build errors. Nope. So I can move around. If I click on here to combat, then we are seeing that bug I mentioned earlier in the video where we are actually calling action instead of current action. So let's go ahead and change that. So let's try that again. Hopefully you noticed that, managed to pick up on that. So I move towards this guy and then I move away. Yeah, that seems to have cancelled it all right. And if I'm moving, I should be able to cancel halfway. Let's see if that's actually working, whether we're actually cancelling movement by, as I said, going to Fighter CS and just commenting out that movement behavior that we're doing. So if I'd done that correctly, now what I expect to see is we're moving, and as soon as I click here, it stops. So just to convince you that this is actually the case, let's click as far away as we can. There you go. I clicked on the capsule. I was clicking over here near the shed. I didn't get to the shed because I clicked on the capsule, and that cancelled the movement. So I'm going to uncomment that again, and we've got the right behavior that we're expecting with no dependency cycles whatsoever, where we can attack an enemy, then cancel that action, move on to something else. So I'm chuffed that that is working as we want it to. We've covered interfaces, we've covered dependency inversion, and I'll see you in the next video where we'll actually be adding some animation. In fact, it probably won't be me, it'll probably be Rick doing that. So I'll hand you over to